Welcome to ZoomInData. In this video, we cover Power Apps interview questions, Power Apps for developers from traditional backgrounds. This session is specially designed for Java, .NET, backend, and full-stack developers who are moving into the Power Apps and low-code world. Small diamond: in this video, you'll learn how Power Apps changes traditional development thinking. Differences between low-code and full-code development. Common mistakes traditional developers make in Power Apps. How PowerFX compares to programming languages. Real interview expectations for experienced developers. This video is highly useful for interviews, real projects, and architecture discussions. Subscribe to ZoomInData for real-world Power Apps interview preparation. 1. How does Power Apps change the mindset of traditional developers? Traditional developers are used to writing step-by-step procedural code, while Power Apps encourages declarative and event-driven thinking. Instead of controlling execution flow manually, developers define what should happen based on state and user actions. The focus shifts from infrastructure and frameworks to business logic and outcomes. This requires unlearning over engineering and embracing platform capabilities. 2. What challenges do Java or .NET developers face when moving to Power Apps? They often expect full control over execution order, which Power Apps abstracts away. Debugging is different because there is no traditional debugger or breakpoints. Developers struggle initially with PowerFX being formula-based instead of imperative. Accepting platform limitations is often the biggest mental shift. 3. How does low-code development differ from full-code development approaches? Low-code prioritizes speed and configuration over flexibility. Many features are provided by the platform instead of being coded manually. Developers focus more on data, rules, and UX rather than technical plumbing. Trade-offs exist between customization and rapid delivery. 4. What concepts from traditional development map well to Power Apps? Data modeling concepts like tables, relationships, and keys translate directly. UI concepts such as events, validation, and state still apply. Security concepts like role-based access remain relevant. Modular thinking maps well to components and reusable logic. 5. What concepts do not translate directly from traditional programming to Power Apps? Threading, loops, and long-running background processes are abstracted. Fine-grained memory management does not exist. Developers cannot control execution sequence the same way. Custom backend logic is limited compared to full frameworks. 6. How does event handling differ in Power Apps compared to traditional UI frameworks? Power Apps uses property-based logic instead of explicit event handlers. Events are tied to control properties rather than lifecycle methods. Logic re-evaluates automatically when state changes. This reduces boilerplate but requires careful state management. 7. How does Power Apps handle business logic compared to back-end services? Business logic often lives closer to the UI and data source. Dataverse rules, validations, and flows replace many back-end services. Logic is distributed rather than centralized in one service. This requires disciplined design to avoid duplication. 8. What challenges arise when developers try to over-engineer Power Apps solutions? Apps become slow and difficult to maintain. Platform features are ignored in favor of custom logic. Complexity increases without real benefit. Long-term scalability suffers. 9. How does Power Apps simplify CRUD operations compared to custom APIs? CRUD operations are largely handled automatically by forms and connectors. Developers do not need to write controllers or service layers. Validation and security are integrated. This significantly reduces development effort. 10. How should experienced developers approach performance tuning in Power Apps? Focus on delegation and data source efficiency first. Reduce unnecessary state and collections. Optimize screen design rather than micro-optimizing formulas. Accept platform limits instead of fighting them. 11. What mistakes do traditional developers commonly make in Power Apps? Trying to replicate full code patterns exactly. Overusing variables and collections. Ignoring delegation warnings. Writing complex logic where simple configuration would work. 12. How does debugging differ from traditional IDE debugging? There are no breakpoints or step-through debugging. Developers rely on labels, notifications, and monitoring tools. Logic must be reasoned visually and incrementally. Testing becomes more important than debugging. 13. How does Power Apps handle data transactions compared to databases? Transactions are handled at the data source level. Power Apps does not provide explicit transaction blocks. Developers must design carefully to avoid partial updates. Dataverse provides stronger consistency than file-based sources. 14. What role does PowerFX play for developers used to imperative languages? PowerFX is declarative and formula-based, similar to Excel. It focuses on expressions instead of execution flow. Developers must think in terms of state and results. Once understood, it becomes very powerful and concise. 15. How does Power Apps encourage declarative design thinking? Logic reacts automatically to data and state changes. UI updates itself based on formulas. Developers describe desired outcomes, not steps. This reduces code but increases the need for clarity. 16. What challenges exist in source control compared to traditional projects? Traditional Git workflows are limited. Solution-based ARM replaces file-based versioning. Merging changes is less granular. Teams must adapt processes accordingly. 17. How should developers rethink error handling in Power Apps? Errors must be handled gracefully in UI rather than thrown. User-friendly messages are more important than stack traces. Retry and fallback logic becomes critical. Monitoring replaces exception logs. 18. How does Power Apps abstract infrastructure concerns from developers? No server provisioning or scaling is required. Security, hosting, and availability are handled by the platform. Developers focus on business solutions instead of ops. This increases productivity but limits control. 19. What design principles should developers unlearn when using Power Apps? Over-optimization before validation, deep inheritance hierarchies, excessive abstraction layers, manual infrastructure management. 20. How does Power Apps change deployment responsibilities? Deployments are environment-based, not server-based. Solutions manage versioning and promotion. Developers work closely with admins. ARM becomes simpler but more governed. 21. What skills help traditional developers succeed faster in Power Apps? Strong data modeling skills, ability to simplify logic, UX and user-centric thinking, understanding platform limits early. 22. How does Power Apps reduce boilerplate code? Built-in connectors handle integration. Forms manage CRUD automatically. Security is inherited from data sources. Less code means faster delivery. 23. What limitations frustrate experienced developers the most? Limited custom code execution, restricted control over execution flow, debugging limitations, platform-imposed constraints. 24. How do developers balance customization versus platform constraints? Use platform features first. Customize only when business value justifies it. Accept constraints as design boundaries. Optimize for maintainability. 25. Why is Power Apps attractive to experienced developers despite limitations? Rapid delivery of business value, reduced operational overhead, strong enterprise integration, high demand for low-code expertise. Thank you for watching. Like the video, subscribe to ZoomInData. Save this video for interview preparation. If you want real-time projects, contact ZoomInData. If you want more questions on real-time projects, contact ZoomInData.